Hello and welcome back. In this video we'll discuss the steps to multi-step equations. First thing is, what is a multi-step equation? Any equation that contains a variable such as, and we've got one right here, 4x minus 5 equals 19, is called an open sentence. Any value of that variable that makes the open sentence true is called a solution, or it's called a root. There are a couple other names, but once we get to quadratics we'll discuss what those other names mean also. Equations that have the same solution, this is key, equations that have the same solution are called equivalent equations. When we go to solve, we are going to attempt to transform the starting equation into simpler and simpler each step of the way, simpler equivalent equations, until we have a single variable equal to a single numerical value. Now when we say single variable, we're talking about just the variable by itself. For example, n equals 5. We don't want 2n equals 5. Here are the actual steps that you can use for almost any of your multi-step equations. There is a PDF of this picture available for download, and you can see right here where it says notes. That is the download link back on MrAlgebra.com. Step 1 is really the longest one. We're going to simplify both sides of the equation, and the steps 1a, b, c, and d may not be done in that particular order, and you may not do all of them, and sometimes you don't have to do any of them. So the first one would be to try to combine like terms, remembering that like terms have to have the same variable with the same exponent, which means you cannot combine an x squared with an x to the third power. Those are not like terms. Another simplifying process might be to distribute. So you're using the distributive property to eliminate parentheses. And eliminating parentheses ahead of time is usually a good idea. Step C, which is not always a required one, is to clear the fractions. And in some cases, when you do this, it will eliminate the parentheses for you. Now, step D, some students have a problem dealing with this, and that is items inside the parentheses cannot be cleared or combined with items outside the parentheses until the parentheses are eliminated. So here's what I mean. If we have a problem in which we have, let's say, 1/3 times 3/4 x plus 5, and then we close our parentheses and we put a plus 2x, and of course we got something else. You cannot combine the 2x and the 3/4 x until the parentheses go away. And if you try to clear the 1/3 on the outside, that means make it so it has no more fractions, it does not affect the 3/4 inside until the parentheses go away. So your options are to either distribute the 1/3 first, or get rid of the 1/3 fraction, and then when the parentheses go away, get rid of the 3/4 fraction. When all that simplifying is done, next is to move your variable to the right or left hand side, and that's only in the event that you have a variable on both sides of the equal sign. Usually what I suggest to the students is move the variable with the smaller coefficient. And if you do steps 1 and 2 fully, chances are by the time you get to step 3, you're only going to have a 2-step equation left to solve. And we're still going to solve by isolating the variable, and the way we're going to do that is apply PEMDAS, and here's the key point. We're doing PEMDAS in reverse. So here's our first example. Step 1, simplify both sides. Well, the right hand side, there's nothing for me to simplify, but on the left hand side I can clear the parentheses by distributing. So what I have is a 3 times the 2x, that's going to give us a 6x, and a 3 times a -3, and yes, that is a -3, is going to give me a -9. And then bring down the rest of the problem that was unchanged, and your equal sign pretty much comes straight down all the time. See if there's anything else I can do to simplify like terms. There's nothing else I can combine over on this side or on this side. So my next step is to go to moving my variables all to one side. Well, I've got two variables. They're both x, and the 4 is the smaller coefficient. So the way I'm going to get the 4x off the right hand side is to use reciprocal operator. So it's a positive 4x, so I'm going to use a minus 4x on this side, and I'm going to do a minus 4x on the other side. And even though that's a subtraction, we could call that the addition property of equality. So this ends up giving us a 0, and 0 plus 7 on the right hand side leaves us with 7. On the left hand side, 6x's minus 4x's leaves us with 2x's. Bring down the minus 9 because that was unchanged. So I've done step 1 and I've done step 2. Step 3 is to isolate the x using reverse PEMDAS. So I'll put a little box around there. It's kind of like an anchor. The number that's attached to that box always goes last, and every other number goes first. So I have to get rid of my -9 first. And the way we get rid of the -9 is to add 9 to both sides using the addition property of equality. I will still have a 2x on this side. -9 and a +9 creates a 0. Bring down the equal sign, and a 7 plus 9 is going to give me 16. And the last thing we need to do is to undo a times 2 by dividing by 2, and that will give me x equal to 8. Another thing you might want to do here instead of divide by 2 is to multiply by 1/2, multiply by 1/2. Since that's the same thing as dividing by 2, multiplying by the reciprocal is sometimes the only way to go, so get used to seeing that. Okay, for this example, we're still going to go back to step 1, which is simplifying both sides. Now I have an x here and I have an x here. However, I cannot combine them together because one of them is still inside parentheses. So the only way I can combine them is to first eliminate the parentheses. There's a minus sign out in front of these, so it's actually -1 times. So what I'm going to distribute here is a -1 to both those numbers. So I'm going to bring down the numbers that are unchanged, which is 3x. So -1 times x is going to give me a -1x. And a -1 times the -5 is going to give me a +5. So that's no longer -5, it's +5. Now, since the right side and left hand side of the equations do not interact with each other until I start going from left to right on step 2, I can actually distribute on this side as well as part of my simplifying. So 2 times x is going to give me 2x, and the 2 times +4 is going to give me +8. Now, a lot of students have a tendency of trying to move the x's all to one side. Well, we're not done with step 1 yet, combining like terms. I can still combine like terms. So 3x minus 1x leaves us with 2x plus 5 equals 2x plus 8. Now the next step is to move all your x's to one side of the problem. Well, since they're both the same, and I minus 2x and I minus 2x, we have a unusual scenario here where both the x's drop out of the problem, and all I have left over is 5 equal to 8. Well, there is the possibility that there's no value of x that makes the statement true. So in this case, you'll see that there's no x's left in the problem, and what's left over is actually not true. 5 does not equal 8. Therefore, we would simply say there is no solution, because there's no value of x you can put back up here in the original equation that will make the left-hand side equal the right-hand side. So this problem, or this equation, has no solution. Okay, so this one looks a lot like the previous one, so we're still going to distribute this -1 here. So bring down the 3x, and we have a -1 times x is a -1x, and a -1 times -8 is going to be a +8. And on the other side, we have a 2x plus 4 by distributing here and here. Combine our x's, so we have a 3x minus 1x, and that leaves us with a 2x. I still have a +8 equals 2x plus 8. And at this point, you can see we have the same thing on both sides. So if you try to subtract your x's, so we have to subtract 2 x's from both sides, our variable drops completely out of the problem, and what's left over is 8 equals 8. And that is true. So in a scenario like this where there's no more variable left in the problem, what's left over is true. What that really means is there are infinite solutions. There are infinite solutions. So it means no matter what you put in for x up here, here, or here, the left and right hand side of the equation are always going to be equal, since on this step right here, the x's cancel out, meaning the x values are irrelevant to the problem. So it doesn't matter what you put in there, there are infinite solutions. Here's an example where we have a distributive property and we have a fraction. Now if you try to distribute that 1/5 to the x and the 3, you'll have fractions inside. My suggestion is to clear the fractions. And the way we do that is we multiply by whatever there is on the denominator of the fraction on both sides. Since this is a divide by 5, we're going to undo that by timesing by 5 and timesing by 5. So when I do this, what I end up getting is a 5 over 1 times a 1 over 5 times x plus 3 is equal to, and I'm going to leave this on the outside for now, x minus 5 times 5. But over here on the left, this gives me 1. And 1 times x plus 3 is just x plus 3. So I bring down my x plus 3. Over on this side, I need to distribute my 5 to both. So 5 times x is going to give me 5x. And a 5 times a negative 5 is going to give me negative 25. Now I have an x on both sides. However, the x on this side has a coefficient of 1, which is smaller than 5. So I'm going to eliminate it by minusing 1x from both sides. Bring down the parts that are unchanged. This is going to give me a 0 equals, and I have a 5x minus 1x, which is 4x. And then bring down the rest of the problem that's unchanged again. So that was step 2. Now step 3 is to isolate the x using reverse PEMDAS. Well, I have a times 4 and a minus 25, and we undo that by adding 25 first. So we're going to add 25 to both sides. This gives us 0, and we have 4x is equal to 28. And the last step is divide by 4, but instead of dividing by 4, I'm going to multiply by the reciprocal. So I'm going to multiply by 1/4, and I'm going to times this one by 1/4. And the 4's will cancel out, leaving x equal to, and this is really 28 over 1. So 28 over 1 times 1 over 4 is going to leave me with 7 over 1, which is just 7. So instead of dividing, you can sometimes multiply by reciprocals, and in some cases, multiplying by reciprocals is the better way to go. Okay, here's another example. Step 1 is to simplify both sides of the equation. Well, on this right-hand side, all we have is the negative 6. There's really not much going on over there. We can't really simplify that side. However, we can simplify the left-hand side. Notice that we have a very large fraction that is divided by 4. So in order to get rid of that, I'm going to times by 4 on both sides. And that's really 4 over 1. So once this cancels out with the 4 on the bottom, all I have left over is a 5k minus 3 times k minus 2. All that happened was the divide by 4 on the bottom was canceled out by the times 4 on the top. On the right hand side, I now have a negative 24 when you multiply those together. Now I still can't combine my k here and here because one of them is inside parentheses. In order to get rid of the parentheses, I'm going to have to distribute not the 3 but the negative 3. So bring down the 5k, that's going to be unchanged. So I have a negative 3 times k is going to give me a negative 3k, and a negative 3 times negative 2 is going to give me a positive 6. Bring down the rest of the problem, that's unchanged. Now combine my like terms. 5k minus 3k leaves us with 2k plus 6 equals negative 24. Now I'm really done with step 1 where I've simplified both sides. There is no step 2 since the variable is already on one side, so I'm going to go to step 3, which is isolate the k using reverse PEMDAS. So I'm going to undo the plus 6 first by minusing 6 from both sides. This gives me a 0, and I still have a 2k equal to negative 24 minus 6. Now you should be able to do this in your head, but you should also pick up a calculator and make sure you get it right. That is negative 30. It is not negative 18. And then the last step is to multiply by the reciprocal, or in this case we could divide by 2. I'm going to multiply by the reciprocal again. I like working with reciprocals because in many cases they're much easier. Put a 1 under the 30. The 2's will cancel each other out, leaving k equal to, and over here we have a negative times a positive, so I'm going to have a negative answer, and then 30 over 2 is going to leave me with 15, and k has to equal negative. Now in all these cases we didn't show this, but you should always take this answer. So this was a negative 15. You should take this number, put it back here and here into the original problem, and evaluate this side of the problem and see if it actually equals negative 6. If it doesn't, then either you made a mistake in your solving process or negative 15 is not the solution.